Okay, so day 8, we're looking at systems of inequalities. What I want to tell you is that your homework, again, is a worksheet. So you're not doing these problems in a book, you're doing a worksheet where I give you the grids already, so it'll be easier to complete. So we are going to look at a system of inequalities. So we are going to have more than one inequality, and we are looking at where they intersect. So, to see this, just easiest to do an example. So you're going to notice we have two different inequalities to graph. This first one has one x, one y, rather. It's going to be a line. It's going to be a line. It's in standard form, so we're going to make that xy chart again. If I plug in a 0 for x, I get 0 plus 2y equals 4. So my y is equal to 2. If I plug in a 0 for y, I get x plus 2 times 0 equals 4. So my x is equal to 4. Okay, so then the first point is 0, 2. The second point is 4, 0. Because our inequality does not have an equal sign, this is going to be a dashed line. So we're going to have a dashed line. And we're going to figure out our shading. If we plug in the number 0, 0, we get 0 plus 2 times 0 is greater than 4. So 0 plus 0 is greater than 4, which is not true. So we do not shade towards 0, 0. Now, we're going to do things slightly differently. When you have a system, you do not care about the individual shading of your two different inequalities. You care where they intersect. So what I'm going to do is I'm just going to indicate that I would shade this way if I were going to. I'm not actually going to shade because all I care about is where the shading intersects. I don't care about that individual shading. I care about where the two intersect. Okay, this second one, standard form, so we're going to make our XY table again. If I plug in a 0 for x, I get 0 minus 3y equals 12. So my y is negative 4. If I plug in a 0 for y, I get 2x minus 0 is less than 12, or equals 12, rather. So my x is 6. So then these are the 2 points that I'm graphing. 0, comma, negative 4 is right here. 6, comma, 0 is right here. I do believe there's an equal sign. There is. So this is going to be a solid line. To figure out the shading, I'm going to plug in 0, 0. So I get 2 times 0 minus 3 times 0 is less than or equal to 12. So 0 minus 0 is less than or equal to 12, which is in fact true. So I'm going to shade towards 0, 0, but remember, all I care about is the intersection, so I'm just going to draw these little arrows. So ultimately, my answer is where the two shadings intersect. The two shadings intersect right here. So any points in that region satisfy both inequalities at the same time. Any points in that region satisfy both inequalities at the same time. Questions? Okay, let's look at the second one. Okay, for some reason, students always have issues remembering how to graph these. We're going to start with the second one, this one. When you have just plain old x equals or y equals, these are still lines, but they're going to be horizontal and vertical. Y equals -1 is going to go through the y-axis. The y-axis is the one that goes up and down. So the y-axis, like it's labeled, y equals -1 is right here. So then we have a horizontal line going through that value. Because of the equal sign, it's going to be a straight line. If we read our inequality, this is a greater than sign, greater than or equal to, greater than goes up. Okay, this first one now. This is two separate lines. We're dealing with the -2 and we're dealing with the 4. Those are going to go through the x-axis. So x equals -2 is right here. That'll be a vertical line then. Because there's no equal sign, it's going to be a dashed line. Same idea. X-axis, x equals 4 is right here. So we're going through the x-axis, so it's going to be a vertical line. And we would shade everything in between those two dashed lines. So then again, ultimately all we care about is where both of those intersections, or both of those shadings intersect, both the blue and red, which would be right here. So all of those ordered pairs are the only ordered pairs that satisfy both inequalities at the same time. On your homework, I expect to see the arrows. If you just draw lines and then some shading, I will not give you credit. The arrows help to communicate to me your thought process. Okay, so then we got two more. We're going to do D, and then I'm going to have you do C. Actually, no, let's look at C. I want you to do C right now, please. So take 2 minutes, do C, and then we will come back together, please. Final answer should be that there's no solution. These shadings do not intersect. Your lines end up being parallel, but then the shading goes in opposite directions. So the shadings will never intersect. How did we do? Anybody get that? A few? It's awesome. Does this seem semi-familiar? Like you've seen it before? Yeah. Okay. You are also going to be able, you're going to have to be able to graph these systems with shapes that are not lines. So we're going to have to be able to do circles and parabolas and things like that. So we have one last example to do. Last example is D. The first one, 1x, 1y, this is going to be a line. Slope-intercept form, so my y-intercept is 7. I'm going to use a slope of 2, so up 2 over 1. Positive slope means my line should be rising. Because there's an equal sign, it's going to be a solid line. When I plug in my test point, I get 0 is less than or equal to 2 times 0 plus 7. So 0 is less than or equal to 7. That is true. So I'm going to shade towards 0, but remember, don't actually shade, just put the arrows. The reason I have you do that is on your test, everything's going to be done in pencil, so you won't have two different colors to differentiate with. Okay, second one. What shape is that going to be? Come on, what shape? Parabola, thank you. X squared is going to have a parabola. Okay, so remember, we did negative b over 2a. What is our b in this case? 0. Yeah, there is no x. So we get 0. To find y, then, we're going to plug in 0. And we get 1. So that is our vertex, 0, 1. Before we even find another point, what do we know about this parabola?
It opens up.
It opens up because of the positive 1x squared. Let's pick another number to plug in. I'm going to plug in x equals 2. So I get y equals 2 squared plus 1. So that is 5. So that is the point 2 comma 5. So 2 comma 5 is up here. And then remember, we talked about this parabola is going to be symmetric. So this is not an asymptote. This is symmetry. So there is a mirror point on the other side. Because there's no equal sign, our parabola is going to be dashed. Okay, and if we plug in 0, 0, we get 0 is greater than 0 squared plus 1. So 0 is greater than 1. That is not true. Where am I going to shade then?
In between the parabola and...
Yeah, I'm shading inside of the parabola, because that's where 0, 0 is not. So then hopefully we can see the overlap is this part right here. So again, that is the only set of points that satisfy both inequalities at the same time.